Hello again, everybody. Welcome back to the custom MobiFlight tutorial series. Today, in part 3, we're digging into the guts of the MobiFlight custom firmware template. If you started with us from the beginning, you've installed the toolchain and tested it out with a quick compile of the default custom firmware. Then in part 2, you took a step back and thought through your design, focusing on getting a screen working, your hardware working, and making sure the SIM VARs you're going to need for your complete capability in your new device are available from the SIM. But before diving into the actual code, let's get our bearings on where our custom code is going to go. So I'm sure you're all MobiFlight users, as that's a definite prerequisite for this series. But you may not have ever looked at the code that makes MobiFlight work. Here's a super high level, many details missing worldview of MobiFlight. This diagram would probably make Sebastian barf, but this is how the software looks in my head. So first of all, there are two main parts. There's the client that runs on your PC. That's the one you're probably really familiar with. Here is the 10.5 version. May have updated since this. This is the original UI. But this is the client software that runs on your PC and connects to your simulator via SimConnect. It's responsible for configuring your devices and setting up all your variables and transitions there. It's responsible for executing that, pulling the data down and sending it to all the different modules. And then you have different modules here, maybe the joystick module, the HID module, and most importantly for us, the MobiFlight Arduino modules. I guess just a side note here, I'm going to be using the word Arduino even if you're coding on an RP2040, a Raspberry Pi Pico, or an ESP32, or even one of the actual Arduino devices. We're all using the Arduino programming framework. That's why I'll use Arduino generically for all of those types of devices. So we're not going to spend too much more time on the client software. The reason I bring it up now, it's written in C# and you'll need Visual Studio to edit that. But it is available on the GitHub if you're really curious about it. It is the heavyweight here. It is doing most of the work. And the reason I bring it up now is the way we talk back and forth between these two is relevant to both of them. And we've got to agree on the protocol that we're going to talk, which is Command Messenger, and some numbers that get passed and forth in Command Messenger. And we will have to set up our device to work to show up in the device configuration. But today we'll do that, I think, in the next one. Today what we're going to do is focus on the MobiFlight firmware, which is running down here on your Arduino device. That firmware consists of a couple major chunks for us. One is that core capability, which includes the message router, pulls data in, and then sends it out to all the different devices. Those devices could be ones that provide input, and the arrow should go the other way for those, like encoders and buttons, or devices that display, like LEDs or 7 segments, or our custom device. Right now, the custom devices are just that, just display devices. They cannot send information the other way unless you do some tricks. But right now, what we're going to assume is what you are creating is some sort of display of information that is coming from MobiFlight. I guess actually this custom device could be lumped up here with the 7 segment and the LED. But since we're going to be making some slight modifications to a file here, we're going to leave it down here. But this is where all the magic happens, is in your custom class. I think that's a good overview, just so you understand where we are putting our code. Now that we've got that, let's flip over to VS Code. And what we see here is that community template that we downloaded, installed, and compiled in part 1 to bring in all the other code. Just as a point of reference, this core code in this orange box, this white box up here, is all under this source directory. But we won't be paying attention to that today. There's a lot of code in there, and you're welcome to take a look. But what we are going to focus on today is under this template directory. And what we're really going to be focusing on is MyCustomClass.cpp and MyCustomClass.h. If you are only familiar with Arduino programming, you may not have seen these extensions before, or you may not be terribly familiar. Let me zoom in a little bit here with the .h and .cpp. If you've only coded in Arduino, you're using C mainly, maybe with a little sprinkling of C++. That's what that .cpp is, C++. And you may not be used to coding in these. You're used to coding in a project name.ino. That INO is essentially a C or a C++ file, but the Arduino IDE does that differently. I'm not going to teach you how to code in C++ in that. That's a pretty deep topic, but I'm just saying this because even if you've only coded in Arduino, I bet you can figure this out and get your information in here. So what we're going to be taking a look at here is this MyCustomDevice class, which is where your code is going to go. Let's take a look. I think I've got a diagram over here. Zoom out, and here it is. So you've got this custom class, and it will have a few methods in here, setup ones, and a few that are runtime ones. Let's take a look at that. I don't know if that was terribly helpful because we've got the header, the actual header file right here. Again, if you're new to C++, a .h file is a header file, and that's kind of like the table of contents for all your code. In your class here, you give your class a name, and then you have these methods, which are functions that operate within a class, and you've got class variables down here that can be private, which are local to the class, or public, which means anybody in the program can access them. These are the ones that come in the template. You'll be adding your own methods and variables down here as you need them. Right now, and again, right now the name is my custom class. We'll be renaming this later, but right now, so we're all on the same page, I'm just going to use the template variable names in here. The custom class has a constructor. The constructor is what is called when you first instantiate the class. And then there are some methods. There are the attach, detach, and begin. These are actually, I would actually put them in this order because the first thing that happens when this class is built is it attaches and all of this setup happens, and then the begin runs, and that's where you would do things like connect your display or set up any other pins or anything you might need to make sure that everything's going to work right. This is almost analogous to the setup function in if you're used to programming Arduino. And then detach happens when it moves out of memory. If most of the controls we build are just going to exist for the lifetime of the device, so that's why you can almost safely ignore attach and detach. When you see these pins up here, these are if you're creating a device that allows the user to configure the pins. If you think back over to the MobiFlight client, did I close it? Oh, it's probably minimized down here. If you think to the MobiFlight client, when you add a new device, you will tell it the pins that a button is operating on. If your custom device requires that, you can pass those in, and we'll show you how to do that. But really, for most of the things that I'm doing, I just take these out and we'll edit things later. Right now, let's just focus on the template. But this is how you can define the pins for your custom devices. So these first three are the setup things. We'll focus on the begin. And then these next two are the workhorses. These are the runtime objects. Set is how information gets from MobiFlight into your device. So let's say that we were doing a speedometer, airspeed indicator, I guess is the right word there. You might, that you would want to push the airspeed, the current airspeed in from MobiFlight into your custom device. It would come into your custom device via this set method or set function. And then you would want to take that information that would be passed as a message ID, maybe ID 0. We'll talk about how to set that, but ID 0, and then the actual value of the airspeed, 101.1, comes in on this set point as a char star, as a string. And then, so now you've read that into maybe a global variable that is my airspeed. And then in your update function, you would update the dial, the airspeed indicator, to show that new value. So the set handles the incoming data. The update is called periodically, or when you maybe you only update it when this set function, the value changes. You would maybe run this update command, or you can set things up so this update command runs every few milliseconds, and then that would update the dial on your display. Right now what we've got is a few variables down here. We could add our own. So like I was saying, maybe we'll have another one that is a floating point, and maybe we do airspeed in there, and maybe we also decide to initialize it here. Out of habit, I'll do that. But we could we could add variables there, and then that variable would be available to my custom class. You could also do them as globals. It doesn't really matter. It's up to you. There's programming style things going on there. Let's take a look at some of these. Let's take a look at the CPP. As I mentioned, this header is kind of like a table of contents. Well, the CPP is the actual content of the book. So let's take a look at this. Let's zoom out. You know what? Let's zoom out just a little bit, or let's give ourselves a little more room to work here. I think this will work. So the functions that we defined over here, and we would say maybe we have another one. Maybe we have a draw function. So draw airspeed. You can add additional functions in here. The little dots mean it hasn't been written yet over in our CPP. Then we come over to My Custom Class, and now we see where these functions are actually written. This is where your code would go. Again, if you're not terribly familiar with object-oriented programming in C++, what this is, you're going to prefix all of these method names with the name of the class, so My Custom Class. And when you see My Custom Class, when you see a function with the same name, that's called a constructor. And that happens when you are declaring the function for the first time, or the object for the first time. And here, when it's created, what happens is it gets passed in two variables, pin 1 and pin 2. If you have more, you can add more. If you don't need them at all, you can take it away. You can take them all away. We'll show you where you do that probably in the next lesson. But this runs when it is created for the first time. You may instantiate, or you may declare some of this. So this is you might also do your airspeed here. You might declare that to be 0 right away too. You could initialize variables here. And then, as we said, the next thing that would get called is the attach. So you're attaching this to memory. And here in the example code, they've passed in yet another pin. I've never really been sure why. They do 2 up here and 3 in the other. If you know why, please tell me in the comments. But in general, most of my objects, my custom device objects, have a lifespan of as long as the power's on for the device. So I usually do not even bother with these two, and I put all of my code into the begin, all my setup code into the begin. So this is where you might initialize display here. You might initialize other libraries that you're using, and you might you're basically, this is all your this is all your setup code that maybe you did in a sample in your test project, in your practice project. This only runs once at the beginning, versus the set and the updates, which will run many times. Okay, so now we've got everything set up. We've initialized our display, we've initialized our variables, we've got everything drawn for the first time, and we are ready to go. So we need to get some data in. You recall, or you may recall, that when we were talking about this, we said that the way the information gets back and forth is through a library called Command Messenger. I think it's really lowercase c. But what Command Messenger does here's a simple Command Messenger command. It looks literally like this. You can see these. I should have set up MobiFlight. If you turn on the debug, you can see these commands in MobiFlight. You can see these commands going back and forth. Usually they'll have them in angle brackets that will show you the actual command. But this is a sample one that would be going to a custom device. So the number 32 is code for set a custom device value. 0 means the device ID 0. So or the first one, as you'll recall, if you're new to C starts counting at 0. So device ID 0, message ID 2. So we can have multiple messages. Maybe your airspeed indicator also has a knots versus miles per hour. Maybe it also has a true airspeed, and so you have maybe multiple message IDs that are coming across. So this 2 is a message ID, and then the actual value comes across, and really I probably should have shown this. It really comes across in quotes, or it comes across as a string. But you can in real life you can actually just type in the number, but it does technically come across as a char star, as a string, as a C string. And oops, some inconsistencies here. I'm sorry if this was confusing. This should really be 29.92 to match up with this. And so this is the value we're setting as a string, and then the command ends with a semicolon. Let's take these out. So often when you're testing, you might open up a terminal window and you can type in this string directly in a serial terminal and have it execute as if MobiFlight was running on the other side. We'll be doing that in some later videos. All right, so with that confusing explanation out of the way, you can see that what happens here is that message ID, which was 2 here, and the value 29.92 is coming in as set point. The core software knew to send it to 32, the custom class, and we can show where that happens later. But for now, what you're focusing on is the message ID of 2 and the set point of 29.92 came in. So the canonical way of doing this is to set up a switch based on the message ID. You'll have one of these cases then for each one of the message IDs that you want to process. For something like an airspeed indicator, maybe there is only 1 or 2 values that are coming in. For something like that Garmin G5 I did, there were almost 100 of these that come in. Basically, there will be one of these numbers for every line in your MobiFlight setup. It almost works out that way. And then what you will have to do is know that in our case 2 was coming in as a, I guess we did 29.92, so we'll say that was the Colesman value. How do you spell Colesman? Is that it? And then you would say that, well, let's pretend it was an airspeed because we set up the airspeed. And then what we would say is for us, we had airspeed equals, and then in this case it was a floating point. Oops, let's see, A to F. And then we would do the set point. Oh, boy, my typing is off today. And so we would, and I spelled it wrong, set point. And so that now our airspeed would be equal to that. You might want to do some error checking around that, or you might get lazy and get lucky. But this is, if you get the wrong types here, you can get some mistaken values, or you might accidentally be rounding your floats to ints. Anyway, that will be in our debugging later. But this is where you are going to take the information from MobiFlight and assign it to your local variables. Make sense? I hope so. And you will just, and then you would just repeat this. So now, and I might do, so case, I would keep adding this. So our third one might be that Colesman. And we'll get an error there because we didn't define it. So we'd have to go to custom class and define our Colesman. Got it? All right. So we would be doing a lot of those, and we would have as many of these as the messages we need. How do we know Colesman is 3? We'll get to that one later. But for now, just know that that's where we're setting things. Now, the final one will be our updates. This is the workhorse. This is this can run either on demand. So you could also say that after this we are going to do an update, or we could also, if we don't want to do it that way, if we want it to run every few seconds instead, because there's a whole lot of these, what we would do is tell MobiFlight to run this update function every few milliseconds. And here maybe we are going to do our draw airspeed function. And that draw airspeed function might say, whatever. We might have a graphics object, and so we might say graphics object draw. I don't have a library installed here. We'll talk about libraries later, but we might say draw string or draw number. Say we're going to pretend it's a digital one, and we might use airspeed here, and we're going to put it at x equals 20, y equals 100, and we're going to do it in TFT red. So this is not going to work because we don't have this declared. We would be declaring that graphics function up here in begin. So up here, this is where we'd be saying whatever, my display, or maybe we're using Lovian GFX, LFGX display. What do we call it down below? GFX, etc. We'd be declaring those, or that would be a variable, and maybe we set it up there. I'm getting over my skis here, so let's just slow down and say that the update function is going to do this, and now it's going to redraw my airspeed every few seconds, or every few milliseconds. So with that quick overview, let's take a breath, let's take a break, and in the next video we will start changing things. We'll start changing some of these class names. We'll start getting into customizing this, so we're not doing this. We'll call it, we'll rename the classes. We will set up all of the necessary files in this community boards and devices so that MobiFlight can be a little more user-friendly when we're setting things up, and we will get it working with the MobiFlight custom class. So hope this was making sense. Please put the comments and the questions down below and let me know what wasn't clear, and I'm happy to go over it again in future videos. Thanks again, and look forward to part 4 soon.